As well as working out the area between a function, in this case two functions, and an x-axis, is that we'll be asked to work out the area between two functions. So to do that, what we do is we'd have to find the area of one between 1 and the x-axis. So we've got our axes there, and say we've got one function. We can work out that area there, and then say we've got our other function, and we'd have area there. And then what we do is we take the top function and our bottom function. We say our top minus our bottom. So that's how we go about doing it. So in this case, what we're dealing with here, and I'll get rid of all that stuff there because I'm going to need that space. You can pause and rewind. So what we've got here is we are looking at we want to find the area between f of x and g of x, in which case f of x is x minus 3 all squared, and g of x is 9 minus x. So to do that, we've got to work out two things: which one is top and which one is higher than the other one, and also where they intersect. So, good idea to sketch these if you can. So, here's something I prepared earlier. Can I delete that? Let's see. Oh, there we go. Now, what we've got here, we've got to try and work out which one's which. So if we have a look at this, we have intersection point here and intersection point there as well. Now, judging also by this, we've got our quadratic and our linear function. As we can see, our linear function is on top. So that's the area we'll be working out first, and we'll subtract that from the other area there. But first things first, let's find out where they intersect. So to do that, we let them equal each other. So we'll say x minus 3 all squared equals 9 minus x. And we go through, if we expand and factorise and whatnot, we'll find that we have x equals 0 and also 5. So this becomes our limits. So I haven't shown you how to do all that. You should know how to do that when you're in year 12. Now from there, what we do is we set this up. So like we said, our g of x is on top. So that's the thing we're going to do first. We're going to say and take the derivative of 9 minus x with respect to dx between 5 and 0. And then we're going to say take away x minus 3 all squared with respect to dx, and we've got between 5 and 0. So what we do with all that, we can set all this up as, so because we're subtracting, we can make this 5 and 0, and then we'll end up with 9 minus x. We expand this, we end up with minus x squared plus 6x plus 9. Oh, sorry, for minus 9 there at the end. Minus 9 dx. And then we need to differentiate. We can cancel some stuff out here. So our 9 and our 9 will cancel. Our x will cancel with one of these 6x's, so we're left with 5x. And we've got a negative x squared there. So this becomes 5 and 0, negative x squared plus 5x with respect to dx. And we can also write that as, let's change it a little bit. Whoops, too far. Press the undo too many times. Okay, we can rewrite that as 5x minus x squared with respect to dx. And then from there, we need to differentiate. So this becomes 5 over 2x squared minus 1 over 3x cubed, and we stick our limits in, 5 and 0. And now, because we've got a limit here of 0, I'm not even going to bother substituting that in, because I know they're both x's, so I'm going to end up with 0. So from here, we're going to have 5 over 2 times 5 squared minus 1 over 3 times 5 cubed. So we end up with, I'm just trying to find some space. I'll undo that. And we've got 5 over 2 times 25 minus 1 over 3 times 125. And from there we've got 125 on 2 minus 125 on 3. And we simplify. These are two fractions. We end up with 125 over 6, or we end up with 20 and 5/6 square units. So, just to recap, we lay out our two functions. Good idea to sketch them to find out where they intersect. The intersection points become our limits. Also, we sketch them to find out which function goes on top. In this case, we've got the linear function, 9 minus x, so we find the area of there first, and then we're subtracting the other area. So we're subtracting that area there. Set up your integrals and go through your anti-differentiation and your substitution process, and you simplify it to find out what your area is.